Article 110.26c of the 2002 National Electrical Code, or NEC, addresses the requirements for working space about electrical equipment operating at 600 volts, nominal, or less to ground and likely to require examination, adjustment, servicing, or maintenance while energized. Specifically, this section covers situations where the service overcurrent protective device rating exceeds 1200 amps. This article states that where the service overcurrent protective device rating exceeds 1200 amps, disconnect means shall be provided in the supply side of the service overcurrent protective device. The disconnect means shall be capable of being locked in the open position. For installations not exceeding 6 feet in height, it shall not be necessary to provide lockable disconnect means. Where equipment rated over 1200 amps is installed, the disconnect means shall be installed in front of and within sight of the equipment. The core question revolves around the interpretation of the term equipment and whether it applies to multiple pieces of equipment, such as two main distribution panels, or MDPs, that are located next to each other. It appears an inspector is interpreting the code to mean that if the combined amperage of the MDP exceeds 1200 amps and their combined width exceeds 6 feet, then push-type open doors, sometimes referred to as crash doors, are required in the electrical room. This interpretation is based on the idea that the term equipment in the NEC refers to multiple pieces of equipment considered as a single unit in this context. However, the correct interpretation of the NEC is that the requirement for a disconnect means in front of and within sight of the equipment applies specifically to individual pieces of equipment rated over 1200 amps. If each MDP is rated less than 1200 amps, the requirement to have the disconnect means in front of and within sight of the equipment does not apply. Instead, the disconnect means can be installed on the supply side of the MDP. To clarify this, consider the scenario presented. There are two MDP, one rated at 800 amps and the other at 600 amps. They are placed next to each other, and each panel is 3 feet wide, with a 1 foot space between them, resulting in a total width of 7 feet. The inspector's interpretation is that because the total amperage exceeds 1200 amps and the total width exceeds 6 feet, crash doors are required. However, this interpretation is flawed. The key is that neither MDP is individually rated over 1200 amps. Therefore, the NEC does not require the disconnect means to be installed in front of and within sight of these MDP. To address this situation and potentially avoid the cost of installing crash doors, there are several steps you can take. Firstly, provide the inspector with a copy of Article 110.26c from the 2002 NEC. Explain to the inspector that the requirement for a disconnect means in front of and within sight of the equipment applies only to equipment rated over 1200 amps. Clearly point out that the MDP in this specific installation are each rated less than 1200 amps. Emphasize that because each MDP is rated below the 1200 amp threshold, the disconnect means can be installed on the supply side of the MDP without violating the NEC requirements. If the inspector remains unconvinced, there is an alternative solution that may help to avoid the installation of crash doors while still meeting the intent of the code. This involves installing a disconnect means on the supply side of the MDP that meets specific requirements. The disconnect means must be capable of being locked in the open position, ensuring that the power can be safely shut off for maintenance or emergencies. It must be rated for the total ampacity of the service entrance conductors and ensuring it can handle the full load of the service. It must be installed in a location that is accessible to qualified personnel only, preventing unauthorized access and ensuring safe operation. By meeting these requirements, the installation will satisfy the safety objectives of Article 110.26c without necessitating the installation of costly crash doors. Let's delve deeper into the specific requirements and considerations of Article 110.26 of the NEC. This article is crucial for ensuring safety in electrical installations, and a thorough understanding of its provisions can prevent misinterpretations and unnecessary expenses. Article 110.26 outlines the requirements for working space around electrical equipment. This space is essential for allowing electricians and other qualified personnel to safely examine, adjust, service, and maintain the equipment while it is energized. The dimensions of the required working space depend on several factors, including the voltage of the equipment, the location of the equipment in relation to other objects, and the presence of exposed live parts. Section 110.26 addresses the dimensions of the working space. It specifies the minimum depth of the working space in the direction of access to live parts, the minimum width of the working space in front of the equipment, and the minimum height of the working space above the equipment. The depth of the working space is determined by the nominal voltage to ground of the exposed live parts and the condition of the installation. Condition 1 applies where there are exposed live parts on one side of the working space and no grounded parts or grounded objects on the other side of the working space. Condition 2 applies where there are exposed live parts on one side of the working space and grounded parts or grounded objects on the other side of the working space. Condition 3 applies where there are exposed live parts on both sides of the working space. The width of the working space must be at least 30 inches, or the width of the equipment, whichever is greater. The working space must be clear and unobstructed and must allow for safe and easy access to the equipment. The height of the working space must be at least 6 feet 6 inches, or the height of the equipment, whichever is greater. Section 110.26b addresses the clear spaces requirements. This section emphasizes that the working space required by Article 110.26 must be kept clear and unobstructed. No storage of materials or equipment is permitted in the working space, and access to the working space must not be blocked by doors, panels, or other obstructions. Section 110.26c, as previously discussed, addresses the requirements for entrance to and egress from the working space. For equipment rated 1200 amps or more and over 6 feet wide, there must be at least one entrance to and egress from the required working space that is at least 24 inches wide and 6 feet 6 inches high. If the equipment is located in a dedicated electrical room or enclosure, there must be at least two entrances to and egress from the working space, unless the equipment is arranged to allow a continuous and unobstructed way of exit travel. As the crux of the matter, we need to remember that the inspector's interpretation of the term equipment is what's in question. The inspector believes that when multiple pieces of equipment are placed together, their combined amperage and width should be considered when applying the requirements of Article 110.26c. However, the NEC typically considers individual pieces of equipment when determining whether specific requirements apply. In this case, each MDP is a separate piece of equipment, and its amperage rating should be considered individually. Since neither NDP exceeds 1200 amps, the requirement for a disconnect means in front of and within sight of the equipment does not apply. To further support this interpretation, consider the purpose of the disconnect means. The disconnect means is intended to provide a way to quickly and safely de-energize the equipment in case of an emergency or for maintenance purposes. When a single piece of equipment is rated over 1200 amps, it is important to have a disconnect means readily accessible in front of the equipment so that it can be quickly de-energized. However, when multiple pieces of equipment are each rated less than 1200 amps, the disconnect means can be located on the supply side of the equipment, as long as it is readily accessible and meets the other requirements of the NEC. It is also important to note that the NEC is a performance-based code, meaning that it sets minimum requirements for safety but does not prescribe specific methods for achieving those requirements. The intent of Article 110.26 is to ensure that qualified personnel have adequate working space and safe access to electrical equipment. As long as these objectives are met, the specific methods used to achieve them can be flexible. In this case, if the inspector is concerned about the safety of the installation, there may be other ways to address their concerns without requiring the installation of crash doors. For example, additional signage could be installed to clearly identify the location of the disconnect means and to warn personnel of the potential hazards. Alternatively, additional training could be provided to personnel who will be working on the equipment to ensure that they are aware of the proper safety procedures. In conclusion, the inspector's interpretation of the NEC in this case is not supported by the code. The requirement for a disconnect means in front of and within sight of the equipment applies only to individual pieces of equipment rated over 1200 amps. Since the MDP in this installation are each rated less than 1200 amps, the disconnect means can be installed on the supply side of the MDP without violating the NEC. If the inspector remains unconvinced, there are alternative solutions that can be implemented to address their concerns without requiring the installation of costly crash doors. Now let's consider some additional details that might be relevant to the situation. Firstly, it's important to verify the specific edition of the NEC that the inspector is using. While the question mentions the 2002 NEC, it's possible that the inspector is referencing a more recent edition. The NEC is updated every 3 years, and there may be changes in the language or interpretation of specific articles from one edition to the next. Secondly, it's important to review the equipment listing and labeling information. The equipment listing will provide information about the equipment's ampacity rating, voltage rating, and other relevant specifications. This information can be used to verify that the equipment meets the requirements of the NEC and that it is being installed in accordance with the manufacturer's instructions. Thirdly, it's important to consider the overall design of the electrical system. The electrical system should be designed to provide adequate capacity for the expected load, and it should be installed in accordance with all applicable codes and standards. The design should also take into account the potential for future expansion or modifications. Fourthly, it's important to document all aspects of the electrical installation. This documentation should include drawings, specifications, calculations, and inspection reports. This documentation can be used to demonstrate that the installation meets the requirements of the NEC and that it has been properly inspected and tested. Fifthly, it's important to maintain the electrical system in good working order. Regular inspections and maintenance should be performed to identify and correct any potential problems. This will help to ensure that the system operates safely and reliably. Additionally, consider the possibility of seeking a second opinion from another qualified electrical inspector or engineer. Sometimes a fresh perspective can help to resolve disagreements and ensure that the installation meets the intent of the code while remaining cost-effective. When communicating with the inspector, it's essential to maintain a respectful and professional demeanor. Clearly and concisely explain your interpretation of the code, providing supporting documentation and rationale. If possible, engage in a collaborative discussion to find a mutually agreeable solution that ensures safety and code compliance. Remember that the goal is to ensure safe and reliable electrical installation while avoiding unnecessary expenses. By thoroughly understanding the NEC requirements and communicating effectively with the inspector, it's often possible to achieve this goal without resorting to costly measures such as installing crash doors when they are not strictly required by the code. Finally, consider the long-term implications of any decisions made regarding the electrical installation. Ensure that the chosen solution is not only code compliant, but also practical and sustainable for the future. This may involve considering factors such as ease of maintenance, potential for future expansion, and the overall reliability of the system. By taking a holistic approach to the electrical installation and carefully considering all relevant factors, you can ensure that the installation meets the needs of the facility while also adhering to all applicable codes and standards.